This video covers RC2. We're only doing one video, one set of notes, one day over reported category 2, and this is everything that's in there. So the first thing that you need to know are the types of slopes. The first one is a positive slope. Positive slope goes up. If you remember watching Slope Dude, he says puff, puff, positive. It increases from left to right. A negative slope goes down. If you remember Slope Dude, he says nice negative because he likes riding down this while he's skiing, snowboarding, whatever. And this one goes down as you read it from left to right. A zero slope is, I'm sorry, this should be a y equals. So go ahead and fix that. A zero slope is listed as y equals whatever, and it is a horizontal line with a zero slope that has y equals in the equation. And then undefined goes up and down. It is an x equals, and it is a vux. Slope is always listed as rise over run, change in y over change in x. And the equation is listed on your formula chart, but y2 minus y1 over x2 minus x1. So there's ways to find your slope when given a couple different things. So the first one is if you're given points. If you're given f of 7 equals 1 and f of 4 equals negative 3, then you need to write your ordered pairs as a table and then use stat edit and linreg. So for this one, remember that x is always inside, y is always outside. So when x is 7, y is 1. When x is 4, y is negative 3. I'm going to take and put these in stat edit on my calculator. So 7, 4, 1, negative 3. If you need a little more time to put these in, you can pause the video. But again, slope is with linreg because it's a line. So we do stat calc option 4. And for this one, it is my a value because a goes with x. So we have 1.3 repeating. Or it might be given to you as a fraction, so you can do 1.3333333 a couple times. Math, enter, and it will tell you that it is the fraction 4/3. It is very, very important for you to understand and know how to turn decimals into fractions because there are times when the calculator will only give it to you as a decimal, but the answers will all be in fractions. If you are given a table straight up, then you need to put that into stat edit as well. And I'm going to make, just like we did in unit 16 a week ago, I'm going to make my table in the calculator look exactly like the table on my paper. Remember that you must press enter between every number. If you need more time, pause the video here. Again, because we are asked about slope, that is linreg. And this time my slope is a nice 1. I don't have to worry about changing it. If you are given a graph, the first thing you need to do is find pretty points. There are 2 pretty points that have been found. Pretty points means that the line crosses at a grid intersection. Like if it crosses very nicely right there, that is an intersection of a grid. So you find nice pretty points. You cannot just try to go from the line to the line. Then you count, so this one goes down 2, right 3. So my slope is down over right. If you will remember to always go from left to right, then you're only worrying about the up or down. Up is positive, down is negative. In your equations, if you're given an equation, your slope is always directly with x, which is what we see from linreg, where a instead of m, x plus b, a and x are together. So whatever is directly with x. So your slope is 1/5 because that's what's directly attached to x. If it is given to you in standard form, then you must solve for y. The way we solve for y is to box whatever's next to around directly with y, move whatever's outside of the box. So x is not directly attached, so we subtract x from both sides. The x cancels on the left and is rewritten on the right. It does not matter if you do 15 minus x or negative x plus 15, as long as you keep the negative with the x and keep 15 positive. Do not combine them and say that this is 15x. From here, we divide everything by negative 5, so the negative 5 cancels here, and we rewrite as seen. And my slope, again, is directly with x. If it is given to you in point slope form, then your slope is directly in front of the parentheses with x. And remember here, just as a side note, that your points are listed as 5, negative 2, because point slope form always has you put in the opposite sign. But if you're given something in point slope form, m is always your slope, so you can just immediately transfer what you see. The last thing we're going to look at for slope on this page is verbal. So Jill has 3 overdue books, and the library charges her 25 cents a day per book with a maximum late fee of $5 per book. So if she owes one book, it is $25 a day per book. I'm sorry, 25 cents. So 25 cents a day. For 3 books, it would be 75 cents a day because we multiply that slope of 1 times 3. So 0.25 times 3 is 0.75. Or if you owe a quarter for 1, it's 3 quarters for 3. We have a rock climber who's descending from a mountain at an altitude of 13.5. The climber can descend at an average speed of 150 meters per hour. So my slope is going to be 150 m per h. So it's just the rate that they have given us. So remember, when you're identifying slope, use the calculator if you can. Find what's with x if you can, or find the word per or the rate that is shown. The other thing in this reporting category is the linear parent function. Your linear parent function has the equation y equals x. The table is shown for you, but you could simply put x into y equals and go second graph to find those points. The graph is also shown for you, but if you were to just click graph on your calculator, you could see it. Your x-intercept is the point 0, 0 because that's where it crosses the x-axis. Your slope, we find 2 pretty points and count up 1 over 1. So your slope is 1 over 1, which is just 1. Remember, if you have a 1 as a slope, if a 1 is being multiplied, you do not have to list it, but it is an invisible 1. If your x-intercept is 0, then your 0 is at x equals 0. And your y-intercept is also the point 0, 0 because that is where it crosses the y-axis. Your linear parent function is one of the only functions that will have the same x-intercept and y-intercept. In order to graph a line, we graph the equation. We begin by writing the equation in slope-intercept form. If it is not given to you in y equals, then you have to change it before you can graph. We then begin with b and move with m. So for this example, we begin at -2 because our y-intercept is -2. You then use your slope to move. So -2 over 3, we're always going to go to the right, so it's just a matter of are you going up because it's positive or down because it's negative. So we will go down 2 to the right 3 and plot a new line. Down 2, right 3. You can also go up and left to continue some points. especially if you're asked information about an x-intercept, but it has not crossed the x-axis yet. My 0 is where it crosses the x-axis. It crosses the x-axis at -3. That is also my x-intercept, which is the point -3, 0. So remember, the word 0 means where does it cross x. The x-intercept also means where does it cross x. Example 2, we're still graphing, but they give us a little bit weirder word problem. They tell me the function f of t equals -0.75t plus 60 represents the amount of water in gallons remaining in a tub after t minutes. So we can use our calculator to find the x-intercept, or we can graph it. So we kind of have a graph started. Remember, we start at our y-axis. And this one's going to be kind of ugly to draw, which is probably why we've been suggested to use y equals. So I'm going to go put this in y equals exactly like I see it. I have -7.5x instead of t plus 60. Now I'm going to use the table to find the x-intercept. When x is 0, when y is 0, x is 8, which is our x-intercept. In terms of this problem, the x-intercept being at 8 would mean after, when t is 8 minutes, the water equals 0. So the tub is empty at 8 minutes. Because at 8 minutes, there is 0 water remaining. Now I can also use this table to plot a couple points, like the point 430 and 615 and 245, so I can kind of see where my line's going to go. And obviously they are emptying this tub because my water is decreasing, or they have a hole in the tub. The 0 is at x equals 8. The slope is -7.5. Those are things given to us. My y-intercept is the point 060. This means when time is 0, my water is 60, and I don't think they told us, oh, in gallons. So this means my starting amount is 60 gallons. So when my time is 0, that's when we start, and the water being 60 at that starting would be my starting amount. My domain for this problem is going to be anything from 0 to 8. Remember that domain is your x values. My x values are down at the bottom. And we can have in between minutes and in between tub amounts. So anything from 0 to 8 minutes would be my domain. Part 4, we're talking about graphing linear inequalities. Inequalities means you have to shade. If you just draw a line, that is not an inequality, that is an equation. So an inequality means you must shade. To graph an inequality, we write the equation in slope-intercept form, begin with b, move with m, and then shade. Also, this is super important. If you divide by a negative, you have to switch your inequality. So in this example, they've asked us to solve for y. They've started it a little bit, so we boxed -2y and moved the -3x. So we have -2y greater than -3x plus 4. To finish, I divide every piece by -2. Because I divided by a negative, my sign flips. -3 divided by 2 is +3 divided by 2. 4 divided by -2 is -2. So we start at -2. My slope is to go up 3 to the right 2. up 3 to the right 2. Because of my inequality, my line is going to be a dashed line, not solid. And because y is everything less than negative 2, less than means underneath, so we shade under the inequality line. Remember, we use the y-axis, the straight up and down axis for this. So we're at negative 2, everything less than goes underneath. And so we shade underneath the line as well. A solution to an inequality is anything inside the shaded area. So for this example, the point 40 would be a solution to this inequality because it's in the shaded area. Oh, look. Is 40? Yes, it is. We just said it was. Is the point 0, 0? The point 0, 0 is out here, so no, because it is not in my shaded area. So inequalities are similar to lines, but you have to look for dashed or solid, what type of line, and above or below. So where is your shading going? The last thing that we're going to look at is systems. So if we have a system of linear equations, if we are given a graph, first thing you need to remember, equations we do not shade because equations mean equal, which means everything on this line. There are 3 different solutions we could have for linear equations. The first is to have one solution, which is the point where your lines cross. So this would be the point negative 3, 1. So you list the one point where they cross. Another option is no solutions, which is the 0 with the slash through it. If you are given straight parallel lines, these lines will never, ever, 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 ever cross. So if your solution is where the lines cross, but the lines don't cross, then there's no solution. The last option is infinitely many, which is the same as all reals or the double R. So you could see any of these 3 things to represent this solution. But it is where your lines are exactly the same. So even though we can't see it, there's a line directly underneath this line. So you have 2 lines directly on top of each other, which means they are touching at every single point imaginable, which is an infinite amount of solutions. The for real last thing is graphing systems of linear inequalities. So inequalities have the little arrows, so you have to shade. One of these lines is already graphed for you, so the y is less than or equal to 3x minus 4. It's graphed, but we need to shade. So this one is a less than sign, so y is less than or equal to 4. So 4 is graphed here, less than 4 is 3, 2, 1, and anything in the negatives. So we shade underneath, and then we shade all the way up to that line. So the line was already graphed, we just had to shade. We are going to do this line fully, so we don't have to solve for y. We start at negative 1, and my slope is to go down 2, right 1, down 2, right 1. You can also go up 2, left 1. Okay, so this one is going to be a dashed line because there is no line under the inequality. Remember, if there's a line under the inequality, like the red one, it told us what type of line to draw. This one has no line, so we have to dash it. This one is also less than negative 1, so less than is underneath the line, and we have to shade everything in its entirety. Now, with a system, the part where they overlap, which is the tiny triangle with the red and the blue, the part where they overlap is your solution. So I've outlined it in pink. Notice that the blue line was dashed, so anything that's directly on this blue line does not count, but anything shaded in blue counts. So the point negative 1, 0, which is right in here, directly in our shaded area is a solution because it is in both shaded areas. The point -1,5 is definitely not a solution because it's in no shaded areas. Something else to be concerned about or to be aware of is if you are given a point that is in one shaded but not both, this is still not a solution to the system. It is a solution to one but not both, and if it's not to both, it does not matter. Remember, on this graph over here, if your lines are parallel and your shaded areas do not cross, then there is no solution. So for this line, this would be the solid line and it's greater than, so it's everything above. This would be a less than, and it's the dashed line, so everything below. There is no place where your shaded areas are going to cross, so there is no solution. There's a little bit of vocab down here for you, which is kind of going over some of the things we've already gone over. It has already been filled in for you, but I would recommend looking over it and letting a teacher know if you have any questions whatsoever on any of the words or vocab.